Hello everyone. Today we solve this question. This question is asked in GATE exam 2023. Okay, this question is from group theory part. Here, phi is a homomorphism which maps the group G to the group Z plus. Z plus is the group under addition and it contains all the integers. Okay, and phi of A is given that 1 for some A in G, means there exists an element A in G so that phi of A equal to 1. Okay, and 1, what is 1? 1 is the generator of the group Z plus. Okay, and what more things are given? G is abelian. What is G is abelian, and phi is surjective. Okay, phi is surjective means it is onto. Okay, these things are given. Let us analyze the statement P. Statement P is what? Statement P is saying for every G there exists an N belongs to Z such that G A N belongs to core phi. We have to show it. Means if we take P statement is saying G belongs to G is given, we have to show that, what we have to show? We have to show there exist symbol. This symbol is called there exist what? N belongs to the set Z such that G A to the power N belongs to core phi. Means we have to show, that is what we have to show, phi of G A to the power N equal to 0, the additive identity of this group Z plus. Okay, we have to show this one. Okay, how can we proceed this to show? First of all, G belongs to G is given. G belongs to G means then phi of G belongs to the range set Z plus. Okay, Z plus means phi of G equal to M0 for some M0 belongs to Z plus. You can write this way or write Z plus. Okay, Z plus means in this way also you can write Z plus. Okay, this one, if we take N equal to minus M0, then what we are getting? If we take N equal to minus M0, don't take this one. First of all, calculate this one. According to your requirement, you will choose what you have to choose your N. Means we have to calculate phi G A to the power N. First of all, calculate this. According to your calculation, for which value of N it should be 0. We have to decide that thing. Okay. So first of all, let us calculate phi G of G A to the power N. According to the definition of homomorphism, phi G A to the power N gives phi of G plus phi of A to the power N, because range set, our range set is Z plus, it is a group under addition, so here plus sign is coming. It is the property of the homomorphism. So it gives phi of G plus it can be written as phi of A times N times N times. Okay, so it gives phi of G plus, it gives phi of A plus phi of A according to definition of homomorphism plus phi of A N times. Okay, so it gives phi of, what is the value of phi of G? Phi of G equal to M0. Okay, because we have assumed it, phi of G equal to M0, this one, so it is M0 and it gives N times phi of 1, not phi of 1, no, phi of A. And what is the value of phi of A? Phi of A is 1 here, phi of A is 1. Okay, so it gives M0 plus N times 1, so it gives N plus M0, because these are commutative, because Z plus is abelian group. Okay, and to show that phi of g a to the power n belongs to show that phi value of the phi of g a to the power n equal to 0 means then we have to, if we take assume it 0, then it gives n equal to minus m0. If we take n equal to minus m0, then we are done. So for every g we are getting a value n which is equal to minus of m0, then our value is phi of g a to the power n equal to 0 means g a to the power n belongs to kernel phi. G a to the power n belongs to curve phi for n equal to minus m0. Okay, so we are always getting these things, means this statement P is true, means P statement is true. Okay, let us check the statement Q. Okay, what Q is saying? Q is saying that E is the identity element of G and A is the subgroup generated by A. Then we have to show that G equal to core phi into subgroup generated by A, and the core phi intersection subgroup generated by A is the identity element. Means what we have to show that Q statement is saying G is equal to core phi times subgroup generated by A and core phi intersection subgroup generated by A equal to identity. We have to show these two things, whether these two things are correct or not, we have to check it. Okay, from statement 1 what we have shown that in statement P we have shown that for any G belongs to G, for any G belongs to G, we have shown that there exist n belongs to Z plus such that G a to the power n belongs to curve phi. We have shown it recently, we have shown in the part to prove part P, means to prove the truth of P, we have shown these things, we have already shown it. So this implies that G a to the power n equal to k1 for some k1 belongs to curve phi. This implies this thing. Okay, from this we can also conclude that, what we can conclude? We can conclude that G equal to k1 times minus a to the power n. If we multiply a to the power minus n on both sides, this gives these things. This implies that G belongs to what? Curve phi, this and subgroup generated by A, means gives for we take any arbitrary G belongs to here and it belongs to this set, means our G is a subset of curve phi times subgroup generated by A. These things we have proved. Okay, and we also know that curve phi subset of G and A subgroup generated by A is also subset of G, because G is the bigger group, so their product is also curve phi times A, also subset of G. This implies this, if we write it star and it is double star, write it double star. Okay, double star, then what? From star and double star we get what? We are getting curve G equal to, curve phi times A. Okay, this statement is true, we proved it. Okay, and one more thing is we have to prove in Q part, that curve phi intersection A equal to E. We have to prove that curve phi, kernel of phi intersection what? Kernel phi intersection subgroup generated by A generated by A is E. Let X belongs to curve phi intersection A, means phi of x equal to 0, it is the definition of kernel, and x equal to a to the power m for some m. For some m belongs to z. Okay. One thing I have written in wrong way. That thing is that I can remember it. Okay. Here n does not belongs to z plus, it is z. Okay, because in the statement it is asking about the z. Okay, n belongs to z, not z plus. Okay, because we are taking here in the calculation, if you look carefully, then you can find that we have taken what, we have taken our n equal to minus m0. It can also be negative, it is not always positive, not z plus, it is only z. Okay, for some m belongs to z, this one. Okay, means x belongs to kernel phi, so phi of x equal to 0, and x belongs to the subgroup generated by A, so x equal to a to the power m for some m belongs to z, not z plus, it can also be negative, here m can also be negative. Okay, if we put these things here, what we will get, phi of x equal to 0 implies phi x equal to what, a to the power m, equal to 0. This implies what, m times phi of a equal to 0 by definition of homomorphism, and the z is a group under addition, from we can conclude this one, and phi of a is value 1, so m times 1 equal to 0, which is m equal to 0. This implies if m equal to 0, x equal to a to the power m, and m equal to 0 means a to the power 0, which is equal to identity, implies x equal to e. So there is no any other element except identity. So curve phi intersection A equal to identity. So statement Q is also true, means we have shown these two things, both the things we have shown. We have shown these two things, this is also true and this is also true, so statement Q is also true, this is also true and this is also true, means option A is saying P is true, this is correct, P is false, this is wrong, Q is true, this is correct, and option D is saying Q is false, this is false. So option A and C are true, A, C true. I hope that you all understood it very well. Thank you all.